Hello everyone and welcome back. My name is Mr. Cobalt, and in this video we're going to consider resonance structures and figure out which one of these is the best. So let's get into this. So we're asked here to consider the three resonance structures shown below for the ion C3H4NO minus. Rank these resonance structures in order from greatest to least contributor to the overall structure. Give a brief but complete explanation. And I'm going to erase this there. That makes the sentence better. Okay, so what do we need to do first? First thing, when you're trying to identify and rank the best and worst contributors to the overall structure of the molecule, you need to assign formal charges. You have to remember that the molecule here is not fluctuating back and forth between all three of these versions. This is just our way of using Lewis dot structures as a two-dimensional structure to give you an idea of what the different forms would be, and kind of helps you see that um, you could have different structures, but it's not like the molecule is really fluctuating or changing from one form to the other. In reality, the actual formula is going to be some average of all three of these. And some resonance structures are going to be more of a contributor to the overall structure than others. And the way you determine that is by looking at the formal charge. So let's do that. So to find formal charge, you have to use this equation. So the formal charge, Fc, is going to be equal to the number of valence electrons that the element has based on its position in the periodic table. So you're going to look at group numbers, and you're going to subtract out 1/2 of the bonding electrons. And so for each bond, you're going to count the bonds around the atom that you're interested in and take half of that. So basically, what this comes to is you're going to subtract out 1 electron for each bond that the atom has around it, because there's 2 electrons in each bond. If you take half of that, that's 1 electron. So basically, you're subtracting 1 electron for each bond that the atom has. And then you're going to subtract out lone pair electrons as well. And that'll give you the formal charge. So let's go ahead and do this. So hydrogen is in group 1, and hydrogen only likes to form 1 bond, right? So for this case, the formal charge would be the valence electron, which would be 1 because it's in group 1. It forms 1 bond, so that's going to be 2 electrons in the bond. Take half of that, that's 1. So you're subtracting out 1 electron for the 1 bond. And they're not going to have lone pairs. None of the hydrogens have lone pairs. So that's going to be equal to 0. So the formal charge for hydrogen is going to be 0. So we could write the formal charges. So formal charge for hydrogen, every hydrogen is going to be 0. Same thing for these. So hydrogen is going to be 0. Hydrogen is 0. Oops. Okay. Now, what about carbon? Now, we have to do these one at a time. So So for carbon, you'll notice it has 1, 2, 3, 4 bonds. And then if I want to find the formal charge of carbon, we're going to take the valence electron. So the valence electrons for carbon is 4 since it's in group 4. We're going to subtract out 1 electron for each bond. So this one has 1, 2, 3, 4 bonds. So we're going to subtract out 4. And then we're going to subtract out lone pairs. But carbon doesn't have any lone pairs here. So that's going to be 0. And so the overall formal charge is going to be 0. So any carbon that has 4 bonds to it and no lone pairs is going to have 0 formal charge. So this one has 4 bonds around it. So this is going to have 0 formal charge. This has 1, 2, 3, 4 bonds around it. That's going to have 0 charge. This one has 1, 2, 3, 4 bonds, no lone pairs, 0 charge. Same thing for this one. Now this one has a lone pair, so we'll come back to that one. This one has 4 bonds, so that's going to be 0 formal charge. This one has 1, 2, 3, 4, so that's going to be 0 formal charge. This one has 4, 0 formal charge, and this one has 4, 0 formal charge. Okay, now what about oxygen? Or let's do this carbon here. So for this carbon, we do the same thing. So again, the number of valence electrons is going to be 4. We're going to subtract out 1 electron for each bond. So it has 3 bonds. So we're going to subtract out 3. And now we want to subtract out the lone pairs. We have 2 lone pairs. So we're going to subtract out 2, add those together, and you get -1. So the formal charge for this carbon is actually going to be a -1. Okay. Now, what about the oxygen? So oxygen here has 2 bonds and 2 lone pairs. So if you want to find the formal charge for oxygen, so the formal charge for oxygen is in group 6, so it has 6 valence electrons. We're going to subtract out 1 electron for each bond. So it has 2 bonds. So we're going to subtract out 2. And it has 2 lone pairs. So that's 4 electrons. So we're going to subtract out the 4 electrons for the lone pairs. And then when you add this together, you get 0 formal charge again. So oxygen, when it has 2 bonds and 2 lone pairs, has a formal charge of 0. So here we have 0 formal charge, right? This one has 2 bonds and 2 lone pairs, so that's going to have 0 formal charge. But this one has 1 bond and 3 lone pairs. So let's calculate the formal charge of that oxygen. So in this case, again, we have 6 valence electrons for the oxygen. We're going to subtract out 1 electron per bond. So that has 1 bond. So we're going to subtract out 1 electron. And then we're going to subtract out the lone pairs. So we have 3 lone pairs. That's 6 electrons. So we're going to subtract out 6. And if you add this together, you get -1. So in this case, the formal charge on the oxygen is a -1. Okay, so we've done nitrogen, carbon, oxygen. Now, last but not least, we have the nitrogen. So for nitrogen, the formal charge for nitrogen is going to be, well, starting with the valence electrons, it's in group 5, for it has So it has 5 valence electrons. And in this case, you'll notice it has 2 bonds around the nitrogen. So we're going to take away 2 electrons. And it has 2 lone pairs. So that's 4 electrons for the lone pair. So we're going to subtract out 4. And that's going to be equal to a -1. So the formal charge for this nitrogen is a -1. So if you have a nitrogen that has 2 bonds and 2 lone pairs, then it's a formal charge of -1. So here we have 3 bonds, 3 bonds, so that's not going to work. So here we have the nitrogen has 3 bonds and 1 lone pair. So let's go ahead and calculate that. So again, nitrogen has 5 valence electrons. We're going to subtract out 1, 2, 3 electrons for the 3 bonds. And there's 1 lone pair, 2 electrons. So we're going to subtract out those 2, and we get equal to 0. So once again, this one has 0, and this one has 0. And so now we have assigned all of the formal charges. So now we're done with that part. Let me go ahead and erase this since we don't need this anymore. Now, what do they want us to do? They want us to rank these resonance structures in order from greatest to least contribution. Now, there's 3 factors we need to consider regarding formal charges. Number 1, the Lewis dot structure, or the resonance structure that has the fewest number of formal charges. So we're going to look at the number of formal charges. How should I say this? The fewer the number of formal charges, the better. Okay? That's number 1. Number 2, the size of the formal charge. So in other words, the bigger, I should say, let me put it in terms of smaller. The smaller, the better. So the difference here, we're looking at just the number of formal charges in that, and we're ignoring 0 formal charges. Since that's 0, we don't need to worry about those, but non-zero formal charges. And then here we're looking at not the number of formal charges, but the size. How big are the formal charges as far as the magnitude goes, right? This is referring to, like, do you have a bunch of 1s or do you have like 2s and 3s, right? And then the third and final one is the negative formal charge should how about this? Is preferred to be on the more electronegative atom. Okay. So those three things you need to keep an eye out on or consider when you're thinking about what resonance structures contribute more or less to the overall structure of a given molecule. So now that we have that cleared up, let's go ahead and look at the Lewis dot structures. So you'll notice here that we have everything is 0 except for the -1 here. So this only has one formal charge. This one here also has only one formal charge. Okay. And then if we look over here, this one also has one formal charge, right? So they all have the same, they're all the same in terms of the number, the sheer number of formal charges. Okay, so we looked at that. All right, so that's not really going to distinguish them. What about the size of the formal charge, right? The smaller, the better. Well, they're all 0, so we're ignoring that except for the formal charge here. So this one's a -1. This one's a -1. And this one's a -1. So they all have the same size of formal charge. So that's not really going to matter, right? That's not going to help us distinguish better or worse. Well, what about this one? The negative formal charge is preferable. It's preferred to be on the more electronegative atom. Okay, so here we might have something. So here we have the negative on the nitrogen, right? And here we have it on the carbon, and here we have it on the oxygen. Now, in terms of electronegativity, if you look on your periodic table, remember when you go across from left to right, electronegativity increases. So you have carbon followed by nitrogen followed by oxygen, right? So electronegativity is increasing this way. So carbon is less electronegative than nitrogen. Nitrogen is less than carbon. Carbon is the greater electronegative atom of the three. So the negative formal charge prefers to be on the more electronegative atom. And so the resonance structure that has it on the most electronegative atom is going to be the more important or greatest in terms of contributing to the overall structure of the molecule. So in this case, this one, where is it? This one would be the most preferred. So if I was to give these numbers, if this is number 1, and this is number 2, and this is number 3, then number 3 would be more preferred, right? So 3 would be a greater contributor to the overall structure of the molecule. And the next one would be where we have the negative on the nitrogen, because remember, nitrogen is more electronegative than carbon, but less than oxygen. So the nitrogen would be preferred next. So then we have the negative on the nitrogen here for number 1. So number 1 would be the next preferred, or the next structure that has the greater contribution. It doesn't have as great of a contribution than number 3 does, but it does have a greater contribution than number 2, where here the negative is on the least electronegative atom of the 3. So then that would be number 2. So that would be the order of greatest to least contributor to the overall structure of the molecule. I hope this is helpful. If it is, then by all means, like the video, share the video, hit the notification bell. When you do, make sure you click all so you can be notified by all the videos I put out. And then also, I forgot, please hit that like button, right? You're sharing the video, you're liking the video, you're hitting the like button. Also, subscribe to the channel. Help me out here. And then finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a question or problem you're struggling with, or if you have a topic that you need help with, put that down below. I would love to do that for you. Thanks for joining me and have a great day.